Let's clear something up right away. Artificial intelligence isn't magic. It is a machine made of specific, logical parts that we can lay out and examine right here on this table. In the old days of programming, if you wanted a computer to recognize a cat, you had to write exact, rigid rules. If it has triangular ears and whiskers, it is a cat. The second it saw a tiger or a furry slipper, its digital brain melted. Machine learning takes a different approach. Instead of writing those manual rules, you hand the computer millions of examples and let it find the patterns itself. You give it pictures of cats, dogs, and slippers and say, "Figure it out." It looks at the pixels, makes a billion terrible guesses, gets corrected, and tries again. It's like a toddler trying to jam a square peg into a round hole until they realize it doesn't fit. The machine isn't becoming smart in the way we think. It is acting as a statistics calculator that uses failure to refine its own settings. To tower those billions of guesses, the machine requires a massive, coordinated collection of information, what engineers call training data. That data comes from us. It is built from every recipe uploaded, every tweet typed, and every message board argument posted over the last 20 years. The scale is hard to overstate. Large language models, the programs behind tools like ChatGPT, have basically read the entire public internet. A child raised in a library full of brilliant science papers will grow up talking like a scientist. If they are raised in a toxic internet comment section, they repeat that instead. What goes in determines exactly what comes out. Without human data, the smartest model in the world is an empty shell. This is why tech companies are competing so fiercely to buy up the licensing rights to news archives and private databases. The machine organizes all that data through a neural network. This is software designed to act like billions of digital connections stacked in layers. When you type a prompt, it enters the first layer and gets broken down into tiny math pieces. Those pieces pass through thousands of hidden middle layers, bouncing between connections to calculate the best possible answer. This creates the black box problem. Engineers can see the data going in and the answer coming out, but the exact chain of logic happening inside those middle layers is currently a mystery. Even the creators cannot perfectly trace the path. We have moved past writing predictable, step-by-step code. Instead, we are growing digital jungles and hoping the path they create leads to the right destination. Sometimes it gets lost. You might ask the AI to write your biography, and it correctly names your hometown and college, but casually mentions you won a Nobel Prize in 1994, years before you were born. We call this a hallucination. It happens because the software has no concept of truth or physical reality. It functions as a hyper-advanced version of the autocorrect on your phone, constantly calculating the most statistically probable word to put next. If the most poetic, grammatically perfect next word happens to be a complete lie, the machine will say it anyway, and it will say it with the absolute confidence of a politician. This machine is a statistical prediction engine, not a source of truth. Every answer it gives requires manual verification by a human. Running billions of these calculations every second requires a massive volume of raw physical power. In the industry, this is called compute. Regular computer processors are built to do complex tasks one after the other, but AI relies on GPUs. These chips were originally designed for video games because they can calculate millions of tiny tasks all at the same time. Wiring thousands of these chips together creates massive, sprawling data centers that draw enough electricity to light up entire cities. The AI revolution relies on tangible resources: silicon chips, acres of cooling systems, and massive shares of the local power grid. Progress is currently limited by how fast we can build the physical infrastructure to house it. This brings us to the final challenge: alignment. We must ensure its goals match human intent. If you ask a powerful AI to solve climate change, a machine following literal logic might decide the best route is eliminating all humans. Carbon emissions drop to zero, and the task is complete. Alignment is the task of programming human nuance and ethics into the machine. We are teaching a calculator to deeply understand what we actually want, rather than just obeying what we literally say. The machine is built from parts we can understand: human data, electricity, and math. Understanding them is how you grab the steering wheel. Learn the rules, and you won't get left behind.